Hello and welcome to the third video in the Quadcopter Building for Beginners series. If you haven't already watched the first two videos, go and check out the links below. In the first one, we did a quick overview of what all the pieces are that you need to build a modern multi-rotor. And then in the last one, we did the flashing of the flight controller, the setup of the radio, and making sure that the receiver was bound and everything was working okay. This time what we're going to do is actually concentrate on the power system, specifically the ESCs, the motors, how they're all put together. We're going to solder on the flying lead for the battery, and then we're going to connect the flight controller, and ultimately we're going to spin the motors, make sure they're moving the right way. If they're not, we're going to reverse them, and by the end of this we should be able to do a test hover before we go any further. And then next time we can actually put the FPV gear in, and the quad is essentially built at that point. Now, I need to say a massive thank you to Drone Authority. Drone Authority were bought as a business back at the end of summer this year and have relaunched on the 1st of December. They have a huge array of products in stock, and the owner has spent hundreds and hundreds of thousands on new stock items to make sure that they consistently have the stuff that we need. So if you are an old lapsed Drone Authority customer, do go and check them out. They're open again under new management, or if you're using some of the other shops and you're struggling to find things in stock, then go and check out Drone Authority. Link is down below. So with that shout out done, let's go onto the bench and start figuring out how we're going to do this power stuff. So this is where I'm up to, and let me explain what I have done to get to here. Now this is the frame. I've taken the top deck off just so I can get to all the components quite easily, and what I've done is I have screwed in the 4 motors, one on the end of the arm. Now each of these motors is identical, so it didn't matter which arm it went on. There is the option to have these 3D printed yellow pieces on the end with this frame. I've opted not to put them on. Now in the actual box with the motors, there are 2 lots of screws, a slightly shorter set, which is what I'm using here. If I was using the longer set, then I would use them with this, or at least for the 2 outer screws, just to provide that protection. I may still put them on, but I'm not sure whether I want these feet. The other little tip is what I've done is I've used a little bit of something called thread locker. Now this isn't necessary, but I find it's very useful, and you'll find that in professional builds that you buy, the ready to flies, they're using this stuff. This is the stuff that you put on just the very ends of the threads, and they are going to make sure that this motor doesn't come off. And you need to make sure that the thread is just coming to the top of these little posts at the bottom. The other really nice thing about this is that in the kit for this frame, SBUS also include these little tunnels, and they are backed with some sticky tape at the back. And what you can do is you can feed the wires through. That keeps the wires in place. If you don't have something like this on the frame that you're building with, then you can absolutely use something like heat shrink or even insulation tape just to wrap around it, just to keep it safe. But this is going to keep the wires from moving around, and it's a really nice touch. There's lots of really cute things in this frame from SBUS that I'm really liking here. So with those 4 motors in place here on the frame, it's ready to put the ESC and other piece in. Now in terms of the ESC, I've done a couple of things on here. First of all is that I've tinned the pads. What that means is put a blob of solder on each of the outputs here, and that will make the connections, when we do that in a second, a lot easier. I've also soldered the power wire on. You need to have a little think and a little test. Now the way this is going to work is the 4-in-1 ESC is going to sit down here right on top of that bit there, and then the flight controller is going to sit on top like that, and that's going to be the flight stack. And we can see that there's lots of room in here. If you look at there, we're just going to fit everything in nicely. It's like it's been designed for it, isn't it? What we need to do is we're going to need to kind of fit this in here. So what I've done is I've soldered the power wires vertically and also fitted this thing here. This little black thing is a capacitor, and the way you do it is there'll be one lead that has like a stripe on it. This one is a gold stripe with a little negative sign. The lead on that side goes to the negative side, and then the positive lead, the other lead, goes to the positive side. Now on this ESC, it's very clearly labeled which is positive and which is negative. Triple check that you are soldering the right way round. Now To solder, you are going to need a decent soldering iron, and you are going to need decent solder. I'd recommend using a lead-based solder. I know lots of people don't like me saying that, but I think for soldering, it's by far the best way to do it. And I would reckon that whenever you're doing soldering, a big tip is you always do the positive pad first. What that does is that also then puts a lot of heat into the PCB, because the ground pins on a PCB actually go all over the place. So there's loads of different parts on here that is the ground plane that's used for lots of different parts of the components, things like this MOSFETs. These are the kind of things that turn the current on and off for the motors. But what that means is by doing the negative pad last, hopefully the PCB has warmed up enough, because it tends, the negative pad just acts like a big heat sink. So that's the big tip. I would always do the negative pad last. So that is where we're up to now. So now we have the ESC, and you'll notice on the bottom it does actually have an arrow saying which is the front, and on the corner of this 4-in-1 you'll see here that it's got numbers. So it's got the number 4 over here it's got the number 2, and this actually matches that little diagram that we had in Betaflight, and that means that the motors are going to connect into the right corners. So the next thing we need to do then is to install this onto the frame, and the way it works is that we actually get with the frame the screws that we need and also the bolts. So what I'm going to do, I'm going to pull these screws out and we'll put them through the bottom here and make sure that they're not going to be too long. We can see here that for this frame it's going to be way too long. However, in the actual frame kit, and if we look through all the bits in here, and this is why I really like these frames, they come with everything you need. One of the things in here is actually a set of bolts for exactly this job. There it is, and it even says on here, screws for stacks. So I'm actually going to use these ones from this frame kit rather than the ones from there, because they are too big, which is not a disaster. This is why we test fit things before we do it. And now we have those 4 screws on, what we can do is we can push our 4-in-1 ESC over the top like that. Now the next job then is we're going to have to solder the wires from the motors onto each of these 3 sets of pads. I would leave yourself a little bit of extra slack. Try and make it as neat as you possibly can, and I give yourself a little bit of extra. So let me go and do that, and then we'll come back and have a look at what that looks like, and we're almost ready to try the flight controller with everything. So here's what it looks like with the other pieces together. So all I've done is I have just clipped and soldered the wires from each of the motors onto the pads. Doesn't matter which way round you attach these, because actually we can change the direction of the motors, and it doesn't really matter which way around they are. We can fix that in a moment. I've done that on both sides and tried to keep the wires a little bit neat and leave a little bit of extra in case I had a problem with one of my soldering joints. The other thing that I've done is I have put the flight controller on, again being very careful to make sure that the arrow on the flight controller is pointing towards the nose of the model, that's the front, and then plugged in a little cable, the rainbow cable that goes from the ESC into the speed controller. This little cable is not only going to take the signals from the flight controller down into the ESC, and then the ESC is going to then route that out into the motors, it's also going to send up voltage and current information so that the flight controller can report on that and tell us what is being used. I've also put the antenna here at the back for the receiver that we've already added, and everything is kind of fitting. Just put the screws on the top of the posts that go through the bottom and we are in really good shape. So the only other thing I've had to do is double check that I haven't accidentally created any shorts that would make the smoke come out when we plug it together. And the way I've done that is I've got my little resistance checker, an ohm meter, and put it on the 2 pins of the power cable here. You should see it initially start at low value, then very quickly go up. And if it increases like that, then you're in really good shape. You can use something like one of these Wi-Fi smoke stoppers. These are fab ways to protect your model when you plug everything in. However, it is just as easy to do an ohm meter like this and double check that nothing is unhappy. So now we're at this point, we're actually about to do something which is always a little bit full of trepidation for me, is that what we're going to do is we're going to power it from a battery and we're going to plug it into the computer, and we're going to check that, one, we can still talk to the flight controller and that's still happy, but also we can arm and turn the motors, and we're going to see which way the motors are turning. So as this is the first time we're going to power the entire system using the battery connector, I have just written down here what the layout of the motor should be and a little reminder of which way each of them should turn. These two motors here should turn clockwise and these should turn anti-clockwise. There's a 50-50 chance that we're going to be going in the right direction. I pretty much guarantee that at least one of them is going to be wrong, probably two. Now I haven't plugged this into the computer yet, because the first thing we're going to do is actually plug it into the battery. A couple of safety things here. Absolutely make sure that you have checked that there are no shorts on this connector here before you plug it in, as I've just shown. And secondly, do not install the props. The props are the last thing that we're going to do before we do a quick test hover, once we're pretty confident that the motors are all turning in the right direction. So this is always is a slightly nerve-wracking bit, but we're going to plug in the lead from the battery, and if there's any noises or smoke or the LEDs don't come on, we're immediately going to unplug it. So let's see. That sounds really good. Now, the reason that we're getting little beeps and the motors are moving is that the flight controller is sending the commands to the ESCs over that DShot 300 setting that we did before. So there's no smoke, everything appears to be pretty happy. Let's plug it into the computer via the USB cable. And first of all, we will just confirm that as I lift the nose of the model up, the nose on the screen is moving, and it is. That just absolutely guarantees that I have put the flight controller in the right way round. That's pretty important. So the next thing we're going to do then is go into the motors tab. And here we can see that's the layout that we've just been looking at. Hopefully that is the way it's going to work. So what we're going to do is we're actually going to move each of the motors. So what we need to do is basically come down here and say, I understand the risks, the propellers are removed. We're going to switch that on. That's basically going to mean that I can now control each of the motors. Now motor 4 should be this front left one here, and it should be moving in a clockwise direction. So what I'm going to do is I'm just going to raise the throttle just very slightly. And I'm going to feel my fingers if it's going that way. And it is. So that's really good news. That also means that the protocol, the DShot 300, is working fine with these ESCs, which is also good. If you ever do this and the motors aren't working at all, it's probably going to be that the protocol is wrong. So motor 4 is in the right place and turning in the right direction. Let's do motor 2 next. It is, unfortunately, it's in the wrong direction. However, it is in the right place. Let's do motor 3, which should be down here and turning in an anti-clockwise direction. And that is the right one, but turning in the wrong direction. And the way it always works is that means then that motor 1 is probably the right way around as well. So as I do motor 1, it should go up. It is, and it's in the right direction. Last test I'll do is I'll just bring the master up just a fraction, and all of them should start at the same time. So let's try that. They look fab. Okay, this is really good news. The problem is though, is that 2 and 3 are backwards and we need to fix that. So what we'll do is we'll disconnect, and we need to download another bit of software called BLHeli. Now, you could just reverse motors 2 and 3 by swapping the connection of any two of the 3 wires going from the ESC to the motor. But you know what? We don't need to do that. If we go here to github.com, I'll put this link in the description down below. You can download BLHeli Configurator 1.2. There's available for Chrome, Linux, Mac OS and Windows. I've got it on my machine here, so let me start it. And when it starts, it looks a little bit like this, very similar to Betaflight. We need to make sure that we're connected to the right COM port, because what's going to happen is we're going to be able to talk to the ESCs via the flight controller. So if I click on connect, and it's important that the system is still powered from the battery, what we're going to do is we're going to click in the bottom right hand corner and say read setup. And here are all of the common parameters here on the left hand side, and on the right hand we have all the different options. Now motors 2 and 3 are backwards, so we're going to reverse motor 2 and motor 3, and we're going to say right setup. That looks like it's worked. We're just going to read setup again, just to read it back in to make sure that ESC 1, which was the right way around, is normal, 2 and 3 are reversed, and 4 is the right way around as well. So in theory, now that should work. So we'll disconnect, the ESCs will beep to confirm. And now if we reconnect via Betaflight, we should now be able to just test those motors are now going in the right direction. Again, we go in the motors tab, we'll go down to the bottom, turn on that we know what we're doing. And if we just very, very gently raise the throttle for 1, that's now going in the right direction. Perfect. And we'll do it for 2 and 3. So 2 was wrong. So let's just see what that does now. That's now correct. Wonderful. Motor 3. That's correct. And motor 4 should be the same too. Fantastic. So that now means all of the motors are safe and we're in a really good state. What I'm going to do is I'm going to disconnect from Betaflight, and what I'm going to do is also unplug the power, because at this point we know that we're in really good shape. The ESCs are going to work fine with the protocol that we have, and we should be almost ready to give it a test little hover. Last thing we need to do is to put on the rotors. Now let me talk about rotors. These are one of those things that you can fall at the last hurdle, because the thing is, if any of these motors are not turning in the right direction like we've just done, then it's not going to fly well, or it'll flip over when you start. There's loads of different issues. Now these are team motor ones. These are 5147s. So what we're going to do is take them all out, and there are different directions. So what you'll find is that there's little bits of writing on the top. You can kind of feel it with your finger. That writing is the top, and you can usually tell that you kind of have the leading edges. So what you'll find is there's 2 of these that are the same. So that one and that one, and there's 2 of the opposite direction. So hopefully you can kind of see that. The way it works is that when the prop is turning, it should be forcing air downwards. So the leading edge of the prop is higher than the trailing edge. So this one has to turn in that direction in order to create a downdraft. So this one is turning clockwise. That then means that that needs to go on a clockwise motor. Let's put that on motor 2. That's going to go over here. The same prop is going to go on the opposite side over here. That means then these 2 props, which go in the clockwise direction, are going to go on motors 4 and are going to go on motor 1. So that is how the props are going to go on. So I just need to install the prop nuts on the top that come on the top of the package, and then we can very quickly see if we can arm and hover this just before we go on to the next piece. There is one extra little thing that I would recommend that we do at this point, just to make sure that we're going to be safe for this test hover. Before you put on the props, I would set the radio up by the side and then plug the power in and flick your arming switch. And hopefully what should happen is all the motors should start turning, ready to fly. This is why we don't have the props on for this bit. Disable the arming switch and all of the motors should stop. Make sure that that works reliably on the bench before we go any further. The other thing we need to do is also make sure that the failsafe is set up correctly. So if we turn the radio off while the motors are running, the motors will stop once the receiver is disconnected. If that doesn't happen, stop what you're doing, look at the information for the radio that you have, specifically around how you set the failsafe for the receiver and system that you're using. If it has a setting, make sure that it's set to something like no pulses if you're using SBUS or CRSF like we are here. So with it all back together and a charged battery on the top, it's time to give it a quick test flight. So let's put it on the ground, put the arm switch to armed, and then gently raise the throttle, and it should rise majestically. If it does, you've done everything correctly and you followed along exactly with the series. If it doesn't, then go back and check something. You've obviously missed something. I'd always recommend doing your test hover over something nice and soft in case something goes wrong. But if you've made it this far, well done. So we're now at the point where the quad is put together and it's flies, or it hovers anyway. That is a great position to be in. Now, if you didn't want to do FPV, you can kind of stop here. Although I would probably continue watching because we're going to talk about the FPV stuff. We're going to add that in the next video and set that up. And then finally, in the last video, I'll probably do some kind of tips and tricks and pro tips of how you can set all this stuff up and make sure that it's safe and easier to fly. So join me in the next video where we'll play with things FPV. Thank you for watching the video. If you watch my videos and find them useful, then please take a moment to hit the like and subscribe button. It helps the channel a lot. If you really like what I'm doing here, you can become a Patreon and support the time I spend helping others and get access to lots of exclusive benefits. Link is in the video description. Remember that all the videos on the channel are organized into playlists, so you can easily use those playlists to find all the videos on a subject that you are interested in. Add Painless 360 to your searches on Google and YouTube, and it'll help you find my content for any particular topic. Thanks again for watching, and as always, happy flying.